The cost of training these models is going down so fast. Like if you invest now, if you buy like a bunch of H100s now, you're just gonna hold on to this very fast depreciating asset. Like if you build up a data set and you keep making it better for like your domain, that thing will still be valuable later. When the newest models came out, whatever, you can plug that thing in.
It's my pleasure to have Matei here this afternoon. So some of you actually went with us to the Skylab this morning, spent some time with Jan and walked through all the various interesting projects. So Matei is also part of the Skylab. So Matei needs no introduction. Matei's one of the, Matei is my hero. He's the guy that created, basically, Spark, Apache Spark, and it permitted the creation of the company Databricks. And many of you follow the company. It's one of the most remarkable success story in enterprise tech in recent times. Matei is currently associate professor at UC Berkeley, and previously he was an associate professor at Stanford. So think about this resume, right? So a PhD from Berkeley, teach at Stanford, teach at Berkeley, founder of Databricks. I don't know what else is possible you can do, Matei. I like to be you. He has a ton of very interesting projects. We only by and large know him by Spark, but there's a very famous project called Mesos at also in Apache, also from the Berkeley labs that he did, and also Matei also founded the Stanford Dawn Lab, and Dawn has a bunch of remarkable open source projects. He's really the guru in open source. And welcome, Matei. Thank you so much for spending time with us and our race partner team. So let me go through some basic stuff. So today we're in Berkeley, and this is a remarkable place. Unfortunately, I only got to spend my first year in graduate school here in Berkeley, and then I got transferred to UC Davis. And now I was I wasn't really working with the cows in the field, but it was kind of within the cows in the field. Berkeley was more fun, yeah. And tell me a bit about that journey. How did you got into graduate school? This is mostly an admiration question. I went to graduate school at UC Berkeley, but I didn't end up with Databricks. I ended up with BEA, which is okay, yeah.
Something, yeah.
But it's not like Databricks. But how did that journey, how did it happen? How do you end up in the lab and that whole thing? I'm sure everybody would love to hear the story. Yeah.
Sure, yeah. First, thanks for having me at the event, and thanks for all your support for Databricks over the years. So how did I end up here, and especially in this space of large-scale computing? So when I was an undergrad, I wanted to see what computer science research is like, and I worked with a great professor at the University of Waterloo in Canada, where I was, and his projects were on peer-to-peer networking and wireless and stuff, so I did some stuff there. But I didn't necessarily want to do networking going forward. I liked, distributed systems and CS and all that, but I didn't really want to do that. And one of the things I liked about UC Berkeley is, this was in 2007 when I was applying for grad schools. This was one of the few places that was looking at data center scale computing, the kind of thing that was happening in web companies, basically Google, Yahoo, maybe a little bit of Microsoft Bing at the time. And I just thought, hey, these are in some sense the most impressive computer applications, as these really large scale ones that work with lots of data that are doing these new things. And that's what I want to learn about. What's the point of being a computer scientist if I don't understand how these things work? And most universities, the researchers there said, we're not going to work on this because we don't understand them, we don't know the workload, we don't have a data center, we have a competitive disadvantage versus researchers in Google, so we're not going to try. But Berkeley was one where they actually wanted to do it because they thought it's interesting. And they had this lab at the time, Rad Lab, which was, the idea was how can we simplify building these web scale applications by having machine learning that manages the data center. That was sort of their idea. So they had machine learning people and computer systems people under one roof, and they were doing stuff. Now, it turned out, when I got there, we looked at the open source things in the space. I was really interested in the data processing ones, namely Hadoop at the time, which Amr was heavily involved in, and MapReduce. And it turned out the lab ended up doing a lot more with like building systems to accelerate machine learning than building machine learning to manage data centers. But the whole point is that they had all these people thinking about this stuff. So that's kind of why I ended up there. I think, again, once I was there, I really became interested in working with open source and like collaborating as a grad student with Facebook and Yahoo and other companies that were using Hadoop really got me to understand the problems in that space. And then I realized like, wow, this stuff is good for companies with like 10,000 software engineers right now, but there are so many other people who can easily collect large data sets. Data storage is super cheap, but don't have the skills to work with them. So like, how can we sort of democratize this? And that's why Spark was aimed at data scientists, people writing Python, people writing SQL, but wanting to run these algorithms. But I saw that because the university was kind of plugged into this stuff.
This is so funny. It's only 3 degrees of separation, and there's a reason why the people in this room are in this room. I remember so clearly that this got to go back at least 10 years ago. I've having a conversation with Ali and having a conversation with Jan on the subject. I would say, well, who would be a great partner to distribute the Databricks product? Obviously, we came up with Cloudera, because Cloudera was religious about not selling a product. So, and let be known, we were little, and then they ended up became our biggest distributor of the Databricks product. And obviously, they never looked back, and we became a much better company. But on the open source subject, Matei, and I wasn't part of those conversations. It was very interesting. This is, I think we were just equally religious about open source at the time, right? For sure, you were a big proponent of it. So this split into the closed source was a tough choice, right? Because now we clearly have a bunch of closed source product. So, what transpired? This would be one thing that I think a lot of our investors and the companies here are very interested in. Say, well, where do you draw that line? How do you go into the closed source? What do you keep in open source? And how can you keep that balance about like being open, letting developer embrace, but yet at the same time, you really have products where customer have to pay, right? Which is obviously, as you heard on the previous fake Alfred, this is my religion, is holding the customer hostage.
Exactly, yeah. Yeah, so it's a great question. So I think, first of all, like what we wanted when we started the company was, to help people do cool things with data and AI. Like the goal was to have impact to like really enable these use cases, however we do it. And open source can help with that, but it wasn't like the main goal was to do some open source stuff. But that's obviously a useful thing, and that also helps you build your product faster by collaborating and stuff. But I think in general, when you build a startup, like you have to focus on, delivering something valuable first and foremost, and like really helping people with important stuff, solving the problem, learning more about it, all that stuff. And then you can figure out is open source, something you want to use as part of that. And I do think, all things considered, if you're just starting a startup, like if you think about open source, it is going to complicate your decisions and your thoughts a lot. So you really have to think whether it's worth it. I do think for areas like where we were in, which is a data platform that's supposed to be like central to an enterprise that like, the most valuable like sort of processing happens on, it's increasingly a thing that customers like require and ask about. They're smart, they're asking about openness and about portability. So like it is important for us. I think in our space, like, you can't ignore it. If you ignore it, you're just kind of sticking your head in the sand and you will miss out. But it's something to think about. And how do you think about where to draw the line? There are a few things. First of all, again, if the goal is to like win, say, the data platform decision, first and foremost, it has to be an awesome platform for what people are doing. So, for example, one of the things we did at the beginning is we built the whole company around delivering this as a cloud service. There were so many customers who said, I'll give you like $10 million if you do Databricks on-prem. There were so many VP of sale candidates who said, I can land you like this many deals in year one. If you do this one weird thing. And we said no, because we thought the winning platforms in terms of simplicity will be software as a service. And that's the battle you got to win. By the way, there's another interesting thing about that. Open source projects are not services. Always our competitor with just say Spark as an open source thing was, that's just a bunch of bits on GitHub, whereas XYZ, whatever the competitor is, BigQuery, Redshift, whatever, is a managed service, and people want the service. So already this is one way you can differentiate from open source. There's no way open source can provide a service, because it's not actually a service. But yeah, that was one thing. And then, what do you gain from open source at a high level? Like, why might you consider doing stuff? One is, your customers are saying they don't want to be locked in. For things like data formats, it's a no-brainer, like, as a customer. Second thing you gain is lots of people who may learn your API, which is awesome. And the third thing you gain is you can share development costs with other people. For example, at Databricks, we started with mostly Spark, and already we had an advantage because we didn't have to create connectors for all these other sources of data. MongoDB, Cassandra, you call it, like whatever thing comes out. Proprietary things like Amazon Kinesis, they built the connector, and our platform had connectors. That's awesome. We also then moved into MLOps, and I actually, co-started this project MLflow with the team. That's an open source MLOps platform. There were no open source ones at the time. Every company was building it internally. And again, we didn't have to build all the integrations with everything and have lots of engineers sitting there. The community built it, and everyone involved benefits. Like for example, Azure ML uses MLflow also. They also benefit, but they also contribute. So that's the other advantage. So basically, like, customers that want may ask you for it. There's sort of the marketing and visibility and training advantage, and there's the shared development. If you don't get these things, it may not be that useful to do open source.
Great insight, and there was a lot of debate was on that subject in the past. I remember the first time I met with Jan and had dinner with him. Before Databricks were even started, we were debating about the subject. Mm-hmm. So let's switch a topic a little bit. I was kind of, I think the folks that went to this Skylab this morning, of course, Skylab's doing Gen AI, et cetera. I think we have converted Jan to believe in Gen AI in the last year. So I'd love to get your take on Gen AI. Like we thought back a dozen years ago to build a huge data platform company was going to be capital intensive. And Gen AI is making it look like nothing, like the kind of money being thrown at it. So how do you see like from the source provider of the knowledge to train the AI, is this even logical, what people are doing? And will this kind of like hurt us or help us, as Databricks, right? Because now we become a big source, especially on the unstructured, and then there's a lot of activity on the unstructured to become structured data. How do you see that all that going to transpire, going forward with this Gen AI stuff?
Yeah, I mean, there's definitely a lot of investment in Gen AI, and I think now a lot of it is in some ways wasted because people are just racing to have like the next like slightly better model. And I do think the cost of building these is going to go down over time, and it's not that clear how far scaling will take you. But I think the real value is going to be in customizing these models for each domain. If you come up with a recipe to do that for your domain, to generate like useful data or collect it, and then of course to train the model, and then to incorporate it into an app that's actually reliable, like that will be great. And a lot of people will do this. So I think it is a valuable technology. At Databricks, we're both users of it. Like we think it is going to transform data platforms. So we got to make sure our platform can use this well. And we're also providers of it. If you're a customer like building AI apps, we can help you with these pieces. We have very efficient training stack, fine-tuning, RLHF, and we also have a really good research team that knows how to do this and has done it for like hundreds or thousands of models already. So both things work. I think to start with, like, let's just think about how it's going to transform software and data platforms specifically. It is first and foremost like an HCI innovation, right? Like anywhere there's an application you interact with, it can become a lot smarter maybe and incorporate natural language. So that's like one thing. So for example, for a data platform like Databricks, you got this great engine to query data, you got data management, security and stuff. But when users log in, the biggest challenge with any data platform is like, how do I even know like which data to look at to ask my question, and then how do I properly formulate the question? Like, and I'm not talking about like, oh, I don't know SQL. I'm talking like, let's say I know SQL inside out, but you drop me into your company and you ask me like, can you compute, churn last quarter in like Europe? I won't know how to do that unless I know how your CFO defines churn. What is Europe for you? Is Middle East part of Europe? Like, how do you define Europe? What is last year? What is your fiscal year? So there's a lot of stuff that, where you have to bug another person or read a lot of documents. And this semantic understanding of data is one of the things Gen AI can help with. The other big one with any data platform is I ran something and I got an error message and like, shoot, that sucks. Well, guess what? Like the most popular AI feature we built is this diagnose error button, where we pass that thing plus a bunch of context into our assistant. We pass our documentation, and a bunch of the time, I think like more than half the time it can fix it, and other times at least it gives you a hint to fix that problem. So these are examples of how for this one software product, Gen AI can help. I think you can think of similar things in other domains, and then whether it like becomes AGI and just starts running your product team for you or not, who knows? It's going to do a lot of stuff in the meantime. But yeah, I think the one tricky thing in thinking about your strategy here is that the cost of training these models is going down so fast. Like if you invest now, if you buy like a bunch of H100s now, you're just going to hold on to this very fast depreciating asset. Like so it's a tricky balance, right? You got to think. But there are other things where as you build up expertise, like if you build up a data set and you keep making it better for like your domain, that thing will still be valuable later. When the newest models came out, whatever, you can plug that thing in. If you figure out, RLHF or whatever, it might be good. Maybe there's a better algorithm published by some Berkeley grad student, but maybe not. Maybe you can still use the thing you built. Yeah.
It's amazing. Jensen Huang is actually a neighbor. And I don't think he will spend, every time when I wave him, even in the car, I think he will stop and say, do you need some GPUs? So.
Well, is it you buy it or you rent it?
I think he doesn't care. However way I like to finance it is not his problem. He just want to make sure there's enough subscription, people want to buy it. Many of the audience here are either direct stakeholders of Databricks through us, or this is probably one of the most sought after participation of anyone that want to be a piece of action at Databricks is incredible. So they're curious, like, why do we ended up spending $1.2 billion buying Mosaic? And then now do we have a project called DBLX that you invented? And then we actually tucked you're telling me, we tucked the whole ML team at Databricks into the Mosaic team to enable them to really embrace them to do stuff. Tell us a bit more about like kind of what are the kind of machine learning and AI activities going on inside the company?
Yeah, I mean, I think at a very high level, I think Databricks has the opportunity to be like the vendor, the platform that best lets you create an AI for like your data, right? The other big ones aren't going for it, and they don't have the thing they're lacking is, first of all, they don't even have access to the data, but they also like don't have the understanding of it. If you build your data pipelines on Databricks, if you do all the data transformation, all the queries, all that stuff, there's a lot of information that can then be used to like train AI that an external vendor won't have. So that's the thing we're going for. We're not making a consumer chatbot. We're not like disrupting Google search, whatever it is. We just want, if you're a company that wants to create AI that works well with your data, we can help with that. And of course, we are also open to like a big ecosystem of like other tools and things that can plug in, because all of those things, we want people to be able to run the best-in-class thing. So I think with Mosaic, we did see, one of the things that really matters in the AI space is efficiency, right? If you have just better efficiency, better reliability, you can train a model or tune a model or deploy a model for lower cost than the other person, then customers will like that. And the Mosaic team was excellent at that. They not only were they really good at computational efficiency, like our efficiency for training mixture of experts is about 2 times more than the best open source frameworks, but also they were really good at doing it reliably. So you just do one training run and it actually works from the first time, instead of you try, it crashes, you have to reset, redo the parameters. So that was their main thing they were doing for people, back then at smaller scales, now increasingly at very large scale. So that was one thing. And then I think the other thing is it was just a strong research team that had figured out a lot of stuff, and we can further enhance that. And we came out of research. We think this is an area where it's worth doing researchy stuff. Same thing as database engines, where we hired lots of database PhDs. We don't call it a research team, but it kind of is. It's sort of, you need the same thing here, and it's a very general technology. For all the other stuff in ML before, the applications were too niche. So having the best, random forest implementation or the best CNN, computer vision or whatever, would only let you get a small % of customers. But having the best language model stack or tuning process or data quality thing or whatever gets you to all customers. Any customer where humans are, talking with their thing, you can get it. Yeah.
It's incredible in this journey, and Databricks now has over 5,500 employees. So doing research is expected because you always have to look 3 steps ahead and then 3 inventions ahead. Otherwise, someone else is going to come up and kill you, and this is normal. So let's switch gear to research a little bit. I know that you have still have PhD students at Stanford, and now you have a bunch of new ones at Berkeley. So you must be working on some remarkable things. Obviously, this audience want to hear, Chris was paying me and said, oh, DSpy, I want to know about DSpy.
Yeah.
So this is going to stay as a research project. Unfortunately, Chris, sorry about that one, okay? But we would love to hear, what do you see? What excites you? Where do you think you want to spend time, and then how you see kind of technology progress from a research perspective?
Yeah, great question. Yeah, I mean, there are so many exciting areas of research happening with Gen AI now. It's hard to tell which one will have the most impact. But the thing I'm most excited about is actually, assume you have a bunch of models, they'll get better. That's okay. But if you really want a high quality AI app, I think you need to build what I'm calling compound AI systems. So you need to build something with multiple components, multiple calls to models, external components vector databases or whatever, real-time data feeds or things like that, and also strategies to call it, chain of thought or multiple generations and filtering. So that's the thing I'm most excited about. The observation is that a lot of the leading results in AI are using that. Also, a lot of the apps developers build. Most of the apps we see at Databricks that people build, even if they're not using our model, they might use our platform for data and ML ops. They are multi-step, chaining apps, RAG, stuff like that. And there's a lot of depth there. So a lot of my research is in this space, and there are some cool problems. One problem is, what's the best design for a given domain? Obviously, lots to explore. Another one is if you make one of these multi-step pipelines, can you automatically tune it? For neural networks, people stuck together layers, and there was this algorithm, backpropagation for tuning all the parameters in concert to meet some objective. We actually came up, and this is the DSpy project by my student Tomar, we came up with a way to do that with pipelines of discrete components. For example, we can learn the best prompts for an LLM for a multi-step pipeline, such as RAG or such as agent-like behavior. And there's a lot of depth to that. And another one is serving these. If I know that I'm not just serving model calls, but I'm going to generate stuff, and then for every statement, I'm going to fact check it and like delete the bad ones. And, can I build a serving system that does that? Or if I'm doing a mixed, like a neurosymbolic app with language model plus, say, a theorem prover or like some reasoning thing, how do I best build that? So this is the one I'm doing the most research in because it's very open-ended and it's very fast to iterate. You don't need to wait for lots of training, and it has a lot of impact, and your results just get better as like better models come out. But there's a lot of other stuff to work on for sure. As I said, at Databricks, like the efficiency angle and of course the data angle matter a lot too.
So Matei, given that, I have a curious question. So we talked briefly about Llama 3.
Yeah.
So Llama 3 is pretty good, right?
Yeah, it's great.
So, and we know that there is a direct correlation amount, like obviously the bigger the model, it gets more costly. The smaller the model,
Yeah.
it's less expensive. So now we're in the dichotomy and say, well, does the big model really buy you that much more in scale while you're spending, if the model is twice as big, you're spending twice the money to train,
Yep.
but yet you're not getting like 2x the accuracy and the results. So where is all this model part of it you think is going, and what will you personally bet on?
Yeah, it's a great question. I mean, the thing that's very weird with language models, and I think no one's like really internalized this because we treat them as people, is they, like all deep learning, they will take all kinds of weird shortcuts to, to try to give you the best answer. And they'll look very impressive. If we ask them things that people know, like at broad knowledge, they'll look very impressive, but they can also fail in like spectacularly bad ways. A student was showing me, I think for lots of models, if you just ask like, is 3 + 5 = 8, they will say no, even like leading leading models. And then they'll explain it and they'll be like, oh, this is why. Like, so there's just, I think it's just hard to bring your own intuition to like, oh, what do I think this thing knows? Like, does Llama know arithmetic or not? Does GPT-4 know it? It's not clear. But on the other hand, there are things they do well. And as I said, I think if you want to build an awesome app, you need to think about the bigger system around it. And you need to think about the evaluation and monitoring and quality improvement process you have. And then you can get something that is qualitatively better. Like, like we're doing with the Databricks coding assistant and with other things like that. So it's hard to tell, I think, how far you'll get with just bigger models. The other thing that I think there is a lot of room for is if you got your own domain where you can get lots of raw data to train with the next token prediction objective, then you can get a model that again learns lots of patterns there. So, for example, you're a healthcare company and you have like lots of medical records. Like you can totally train something that will be better at medicine than something trained on the web or by buying like a zillion textbooks, right? Like imagine it's like you go to a doctor that's seen 1 million patients with your condition. That's pretty cool, right? I'd rather go to that doctor than someone that is really good at playing chess and doing math, but has only read like the textbooks, right? Because they don't have the hands-on experience. So I think if you're building, if you are in that domain where you're lucky to be data rich or you can generate synthetic data that's useful, then I think you could do amazing things by training on that domain. If you're in these other domains, then I think you have to think about the system, and you could still do some pretty cool things, but there's more engineering. It's not just like put in a bunch of data and turn on the button and like wait for a month. Yeah.
Thank you. So with that, anyone have any questions for Matei?
So just to follow up on that last part, when you think about Fortune 500 companies, or take your healthcare example, to really harness and build those use cases, two things. One is, do you find that they're sophisticated enough to get their data structured appropriately? And second, from a talent perspective, since you need that kind of intuition for what an LLM is good or bad at, and meanwhile they can come to Silicon Valley and make decent money, are they getting the right talent to actually build these amazing things?
Yeah, it's a great question. I think it will take time, I think, for the talent to really diffuse, but people are learning and experimenting. And I think also as the cost of training like a reasonable size model goes down, more of them will do it. The data part's also really interesting. Like on the one hand, yes, you'll do a lot better with like really clean, really high quality data. On the other hand, the stuff we put into like language model training is a lot of junk. It's like random stuff from the web, and they still learn some stuff is like less trustworthy than other things. So they are surprisingly resilient. Yeah, I do think the big part is this cost. And I think we've been seeing the cost of getting the same quality model is going down something like 4x year on year, with 2x from hardware improvements and 2x from algorithmic. So hopefully in a few years, a lot of people will experiment. Yeah.
And is the cost going down for a net new base model, or is it mostly just from the fact that you could leverage a lot of the existing?
Yeah. I'm talking about net new base model actually here. So for example, the same team, the Mosaic team, built DBRX this year, which is like above GPT 3.5 model that's like twice as fast for inference as Llama 70. And they were building, like 12 months ago, I think they had built MPD 7 billion. They were working on 30 billion. And we as part of building DBRX, we also rebuilt multiple models with the same capability as MPD 7 billion, and we could do those for 4x less now. So the combination of algorithmic improvements, which are mixture of experts plus better data cleaning, and hardware improvements, the cost of all the GPUs went down. And that's something they observed over time even before. So I think some amount of that will continue. Yeah, if you're also, if you are reusing data sets or you're using one model to supervise the other, that's an even bigger advantage. Yeah.
So I have a question. You said that instead of using one machine learning model, go for the depth, so that you can use several of them and then being able to fine-tune each one of them at the same time. What would be the example of the application for such thing? Like, why would you say go with that way?
Well, so there are a lot of different cases, but a good example is like, let's say you want to have better reasoning for a problem. Like, let's say you're using, you take the best model today, maybe GPT-4 or Claude or whatever, and you want to solve like some math problem or some physics problem. It turns out if you run it multiple times and tell it, give me a solution to this, and then you tell it, judge these solutions, which one is the best, you get a better success rate than if you just call it once. So that's what I mean that's what I would call a compound system that like does multiple model calls. So you pay more, but you get a better model, but it might be totally worth it. And you don't have to train a giant model either. You use your existing one, just call it many times. And then if you also add in external tools, like it can use a calculator, or it can use a search engine, or whatever, it can write a program and run a simulation, it gets even better. So that's why I'm saying like the leading results are obtained with these. AlphaCode from Google, which is the sort of the best coding AI system, calls models 1 million times to solve a programming problem, and then filters the result, clusters, filters, and picks the programs that like look like the best candidate. And same thing with their math one, Alpha Geometry, lots of calls to models.
So you're talking about the calls, not like the usage of different models.
Yeah, you could also do different ones. Yeah, it's a mix. Like actually, AlphaCode has different filtering and generation ones too, but it could be either way works. Yeah, I'm just saying you got to think about a system. You don't just think about one big model, but think about, hey, can I mix and match components? Like in programming, you got modular components that do one thing. Yeah.
We'll take one last question. Anybody? No good. You're going to ask if you're real word or AI?
Yeah, it's this who's.
I have to have a disclaimer. So, what do you think of the the scaling load? Like yesterday, like the Llama 8 billion, they trained it on like 15 trillion tokens, and now it wasn't even like it didn't converge in at the end, right? Do you think like the future here is like for more larger models, like and continuing like to go larger, or like smaller models and like jamming more data?
Well, it's a great question. So both things can work. So I mean, the neural scaling laws, if you read the paper, it basically says that your model quality will increase with both the number of parameters and the number of data tokens you train on, and there's diminishing returns on both, and they're kind of like multiplied in a specific way. So it does say that, like the same model, the Llama 8B, if you keep training it, the trend is it does get a little bit better, but there are diminishing returns. And same thing if you increase its size and use the same amount of data, it'll keep better. But eventually, for a given data size, like there are diminishing returns to increasing the number of parameters. So really the choice, but you can plot all these. You can take all the open models where people have published a number of tokens and parameters, and if you plot them on a curve, it's very predictable, the end quality from the total tokens times data. It's super predictable. There are differences as people improve their data mix and stuff, but that stuff is not, overall it's still the total amount of flops you spend. Whether you do big ones or small ones kind of depends on, do you want to spend more time training to get cheaper inference cost? And it's less efficient. Like if Zuck just wanted a model with a certain quality, actually both 70 billion and 8 billion are too small. If he had a fixed budget and he wanted the best model, he should have made a bigger one with his data. But if he wants to deploy it, like maybe training an 8 billion one is totally worth it.
All right, with that, Matei, thank you so much. It's so good to see you, especially in Berkeley. Thank you for doing this for our group, and be more appreciated.
No worries.
Thank you so much. Yeah. All right. Okay. Thank you, Matei.